In this lesson, we're going to examine another type of continuous distribution, kind of the focal point for the rest of the unit. We're going to call this one the normal distribution. This circumstances arises when you look at a whole bunch of data that can be measured. For instance, we looked at everybody's heights in the school. If we measured them all, we'd get a shape that's symmetrical, like this. We have a couple of short people, we have some really tall people, but most of our people would be kind of in the middle. And, in fact, the middle would be the most common thing to find. And as I was saying, this happens anytime we have a whole lot of continuous data. It doesn't have to be heights, it could be weights, it could be marks. It could be how long it took you to get to school today. Some are short, some are long, most of us are kind of in the middle. And we call this symmetrical, but what I'm going to most often refer to it as is the normal curve or the bell curve. So 3 names to remember there. Symmetrical means normal, means bell. If we know things are normally distributed, if we're told that, or we've done some data and some analysis and we've made a histogram and graphed it, it turns out that the mean, the median, and the mode all have exactly the same value. In fact, if we draw it out, the number down the middle is the mean, exactly halfway, which is the median, and it's also the most common. Our big idea we learned yesterday is if we want to find the probability of continuous things, we want to find an area under the graph. Well, we can do that with normal things. Okay. Because it shows all of the different possibilities, we know that the total area adds up to 1. So if we can find a proportion under a curve, let's say if my graph was this one up at the top and I want to find this proportion, well that, I don't know, third or quarter, whatever it is, under the graph would refer to the proportion, which is also the probability of percent. Okay. So our objective with this normal graph is to find a range and figure out the probability, the proportion of the curve that's been included. Okay. Usually when we start, we label the middle number. This would be our mean, which is also our median, which is also our mode. And kind of nice, if it's in the middle, if it's the median, we actually know that this percentage is 50. And this percentage is 50. So that's kind of a starting point for us. But we can also find other probabilities based on some kind of cool patterns. Here are 3 of them. Okay. Mean, median, mode in the middle, 50% for sure, all the time. But if we actually examine our standard deviations, we can find 3 other kind of handy probabilities. It turns out that 68% of your data is always within 1 standard deviation of your mean. So if I were to look at my graph, and I've expanded it here, my mean's right down the middle. If I go 1 standard deviation above it and 1 standard deviation below, and I get this range right here, it's approximately 68% of my data. Not exactly 68, what I could have a little bit more decimals there, 68.26, but we'll call it 68. 1 standard deviation. If we go to 2 standard deviations, 95% of our data is within that range. Okay, so if I took my mean, I went 2 to the right, I add 2 standard deviations. I go 2 to the left, I get from here to here. That's 95% of our data. Again, it's not exactly, it's slightly more than that, but we can call it 95%. And then if we go 3 standard deviations, it turns out that we have 99% of our data. Almost all of our data is within 3 standard deviations of average, of the mean. 99%. Which really means that beyond 3%, there's really only a total of 1% left over. And if you think about it, that means like this tiny little bit over here has got to be like 0.5%, 0.5%, like. And this half over here is going to be 0.5%. It's so rare to be beyond 3 standard deviations, you will rarely see that because it's very unusual. It's like we looked at the heights in our school and then we found someone who was 9 feet tall. They're so far beyond normal that they're in one of those extreme cases. Okay, so I kind of need you to remember these 3 numbers. So 68, 1 standard deviation, 95 is 2, 99 is 3. It also helps remember the 50-50 idea down the middle. How do we make this work? Well, let's look at an example. So the chest measurements of soccer players are normally distributed with a mean of 95 centimeters and a standard deviation of 8. My suggestion when we examine one of these problems is to draw a picture. So what do I know? I know right off the bat it's going to be normal because it tells me that. I know right off the bat down the middle is a mean of 95. Now I can add some more numbers to that because I was told something about the standard deviation. The standard deviation was 8, which means if I go 8 units to the right, that's 103, that's one standard deviation. I go 8 more units to the right, it's 111, and one more, I can go to 119. There's my 3 standard deviations above. Do the same thing the other direction. I go down. 95 minus 8 would be 87. Minus 8 more would be 79. Minus 8 more would be 71. Notice my bars are roughly the same size. And based on the diagram, I can now answer some questions. Let's try part A. Find the percentage, percentage is another word for probability or proportion, of players with chest measurements between 87 and 103. So I'm looking for the probability they start at 87, go all the way up to 103. Well, those are nice numbers on my diagram. 87 to 103, if I recognize that, is this part of my graph. Well, that's one standard deviation above and below the mean. I know that number. That number is 68%. No math required. Just recognizing that that's one standard deviation from the mean. Okay, let's try B, or part 2, I guess. Part 2 of that question. How about 103 to 111? Okay, 103 to 111. Ooh, I see that. That's right here. That's this segment of the curve. So, some things to think about. If I memorize the numbers in the graph, in these proportions, I might remember that this was, I don't know, 13.6%. If you can remember that, go for it. Totally makes sense. You can remember, not a big deal. But if not, I can still figure it out by thinking a little bit. I know that this is 2 standard deviations, right, above. Well, 2 standard deviations is 95%, but I really only want the right-hand side. So 95% divided by 2 will give me 47.5 from the mean up to here. Now, I don't want all of that. I kind of need to get rid of this section. Well, that section is 1 standard deviation from the mean. 1 standard deviation of the mean is 68. And 68 divided by 2, because I'm only dealing with the right-hand side, is 34%. So I know that if I include from the mean all the way to here, it's up 47.5. But if I get rid of this section, 34, I'm left with 13.5%. Now, as I said, if you can remember, it's 13.59 or 13.5. Totally works, right? That's what the number is right there. But I can also figure it out by thinking about this a little bit. Let's try part B. Okay. Find the probability that the chest measurements of randomly chosen players between 87 and 111. All right, 87 to 111. Ooh, I got a messy diagram going on here. What do I know? 87 is right here. That's 1 standard deviation below. That's 2 standard deviations above. Now, I already figured out that from here over 2 standard deviations is 47.5. I also know that this is 1 standard deviation below, and we figured out that that area, 68 divided by 2, is 34. So if I take my 34 and my 47.5 and I add them together this time, because I want on both sides of the mean, I can figure out the probability together would be 81.5%. Now, again, if you can remember some numbers, and you're okay with remembering numbers, I don't mind that. And I know that okay, one standard deviation is 34 and one's 34, and the next one's actually 13.5. Well, if you take those numbers and add them together, what do you get? 81.5, right? Same thing, maybe just a little bit faster, but you got to remember what those numbers are. And some of us might be better at that than others. Okay, last example, you guys pause the video, try it yourself, see if you can figure it out. If not, turn back on and follow along. The weights of 10,000 students are normally distributed. So I know right off the bat, it looks like that. The mean is 55, the standard deviation is 5. So I've got a 60, a 65, 70, a 50, 45, and a 40. Okay. Find the number of students weighing between 50 and 60. Before I find the number, I got to figure out the proportion of people who weigh between 50 and 60. Nice news is that 68% of my data, because it's one standard deviation, and 68% of 10,000 people, I can multiply that. I'll get 6,800 people. Let's try B. Number of students weighing less than 45. Okay, below 45. Below 45. Ooh, that's way down here. Below 2 standard deviations. So, 2 standard deviations. What do I know about that? I know that's that. That's 2 standard deviations. So 95% divided by 2 is 47.5 for this part. And I actually know that the rest of this graph, all the way up, even beyond 3 standard deviations, is 50% of my data. So if I combine those two things, 47.5 and 50, that's 97.5% of my data from here over. How much does that leave me below 45 then? 100 minus 97.5 gives me 2.5%. Okay. How many students were we asked? Well, 10,000 times 0.025. Oh, that's 100,000. Let's try 10,000. Would give me 250 students. Way below 45 kilograms. Okay, find a range of weights that would include 99% of the measures. 99, that's one of my favorite numbers, because I know that 99 is my mean plus or minus 3 standard deviations, which on my diagram is 40 to 70. So 99% of people would be between 40 and 70. I'm sorry, I shouldn't have an equal sign here. Okay, there's the normal distribution. So we're going to play with these 3 numbers, 95, 99, and 68. Sometimes you got to divide them by 2 because you want to work on one side or the other. Sometimes you have to add or subtract. As I said, if you can remember those 3 numbers, great. If you can remember the other numbers, okay, like 34 and 34, and then 13.5 and 13.5, and then the other ones, I don't remember the other ones. What are the other ones? 2% basically. Okay. You can totally work with those numbers. I'm totally fine with that if that helps you. Okay. But I think the 68, 95, 99 should be enough as long as you stop and think about adding and subtracting your numbers together. Okay, our homework today is a handout. Answers are on the website. You can check them out, try them. There's just a couple of questions there. Make sure you can practice with these numbers. And then we'll move on to more something new.